Yeah.
All righty. Good morning. Like warriors. So, a couple of reminders. That's reminders that come before we need to be reminded of them. First off, your test is 1 week from your test. 1 week today. Also, next week, Tuesday, we would ask that you bring your Chromebook and social security number if you haven't registered for a dual credit course. If you have registered for a dual credit course, then bring your NTC ID and your login and password and all that fun stuff. Yes, sir.
If you don't remember that stuff.
Then bring your social security number because that's what the question is to ask to find it. So, yep. So there's that. Tomorrow. So first off, let's talk the formative that we took on Tuesday. The formative we took on Tuesday, those corrections can be turned in at any point in time. If you want to check your answers before you turn it in, that's 100% a good idea. And you can do that with any of the three of us. We all have the answers with us. And then you can turn it back into your grading pass. Tomorrow, we're going to take another formative, okay? And that's going to include P5 on it. So it'll be all of the P's minus P7. I don't know, we'll probably do some P7 on it. Yeah, we'll probably do some P7. Yeah. Good times. Okay? All right. Let's do this. So I think this warm-up is not in your, it's not in the packet. So it's just kind of an off to the side or at the bottom or somewhere that you got an open space in the packet. If you could solve x squared minus 3x minus 10 equals 0 in one of the methods. Remember, we got 4 methods to solve a quadratic now. We've got factoring, we've got completing the square, we've got quadratic formula, and we've got graphing. So we've got all 4 methods to choose from. Please give it a good solve. Ready, steady, go. Now, the cool thing about the 4 methods is it doesn't matter which one you choose. You're all going to get the exact same answer. Okay? All right? So, for me, I'm going to go, because, factoring is my favorite F word, I'm going to go with factoring, because it is factorable. Okay? So, 2 numbers that multiply together to be negative 10 and add together to be negative 3 are negative 5 and positive 2. So it factors to be that. Okay. Then I can say x minus 5 equals 0 and x plus 2 equals 0. And then I can add 5 to both sides here, and I can subtract 2 to both sides here, and I can say that my 2 solutions are x equals 5 and x equals negative 2. If you graphed it, okay? And you had to find the zeros, okay? Or the intersections you put in the 0, and you should have gotten 5 and negative 2. If you quadratic formulaed it, it should have been a nice, perfect, no radical type one. And if you completed the square, you chose the wrong method because completing the square is not so easy when it's an odd b value. All right. This one is back a little bit. It's in the, I think it's on page 4. Yep, it's at the top of page 4. Okay. Okay. So if I want to solve this one graphically, I've got 2 choices. Remember from yesterday, we had 2 choices on solving things graphically. I can put the left side in as my first function. I can put the right side in as my second function. And then I can look to where the left side is below the right side graphically. I can do that. Okay. Other option is I could move the 6 to the left side and then I would look for everything that's below the x-axis. Okay? Should get the exact same thing. So x minus 1. All right, so I'm going to go to my graph, and I'm going to say that I want the absolute value, and then side note, fractions. We can do fractions on these wonderful things. It's control divide sets up the fraction for you. Control divide sets it up. And then we said it was x minus 5 and 4. X minus 5 and 4. Enter. Boom goes the dynamite.
How do you make like the whole page?
You can, the whole page, you can take your cursor and grab onto an axis. Yeah, and then slide it in. Then I need to tab it, and I think we said, whoa, hey, no, it's escape. We need to tab it, and we need to go 6. And there it is. But rut row, what's my rut row? Tab. We gotta hit enter first. That one that says enter. And you can tab and 6 it. Yeah, enter's the one that says enter. Okay? So I can't see my what?
I don't know.
I can't see my intersection points, right? Okay, so I've got to shrink the graph somehow. So I'm going to move my cursor onto one of the axes, and I'm going to slide it towards the middle a little bit more, and then that way we can now see those 2 intersection points.
It's not working.
Yeah. Other option, if you don't want to grab onto an axis and slide it in, you can adjust your window settings in menu, window, and zoom, and then window settings. And you can say, well, I need to go all the way out to -22 and 31. That's what I just had to do to see it. And so you need to go past that to see it.
So
Listening.
mine isn't like zooming it in and out, it's just moving it.
So then you need to grab, you're not grabbing onto the axes.
Okay.
Yeah. If it's just sliding it back and forth, then you're not grabbing onto the axes. Menu, analyze, intersection,
Got it?
menu, analyze, intersection. Yep. So what is the solution to this graph, or to this inequality? Where the points intersect, is that the solution? Just -19 and 29. And everything within it, right? Because what this is saying is we want wherever blue is below red. Okay? So we want to put that in one of 2 different ways. We could put that in inequality. Or we could put that in interval notation. One of those 2. Okay? Okay? But just 19 and 29 would not work for that one. Okay? If it were an equal sign in the original equation, yes, then it would just be those 2, 19 and 29, -19 and 29. Okay? Going the wrong way.
Yeah.
Try that one. Go. So I'm not even going to graph this one on the calculator. Because I know, because it was the warm-up problem, I know that it goes through the point -2 and +5. And being that it is a quadratic, that makes it a parabola, because it has a positive a value, I know that it looks like this. Oops, wrong one. That should be -2. Okay, I know that. So this is asking me where the parabola is greater than 0. So that would be where the parabola is above my dashed line. Well, that would be from -∞ to -2. And again, it would be from 5 to 0. In an inequality, that would be x is less than -2 or x is greater than 5. Yes? Oops, that should have been an infinity. Good eyes. Is that better? 5. Love it. Good times. All right, now let's get into P7. Projectile motion. Okay? Sometimes you got there it is. My objecto. So a projectile that is launched vertically, okay? What's going to happen to it? Gravity's going to, so it's going to launch at a certain velocity, right? Okay. Depending on what velocity I put. Okay. Right. It can go, the higher it goes, the more velocity I put into it, right? Okay. So then it goes up and up and up and up and up. What happens to it while it's going up and up and up and up and up? It's slowing down because of what? Gravity's taking hold. Eventually, it's going to go up and up and up, and then it's going to do what? It's going to stop for just a brief moment. And then what? It's going to fall right back down. Okay. Right? It's going to accelerate back down. Okay? Until it hits the ground. Hits something. Okay? Now, we are assuming in this scenario, we are assuming that we're in a vacuum. Okay? So we're assuming that with no wind blowing, no anything like that. You know what I mean? So the only constant that's being affected on it is gravity. Okay? So if that be the case, then we can model the height of our object using -16t squared plus v sub 0 t plus s sub 0, where v sub 0 is my initial velocity, t is time from launch, okay, and s sub 0 is the initial height that I launched it at. Okay? So if I'm holding it out here, it's 3 feet above ground, okay, or above the ground, above the floor, I should say. I'm launching it at +3 for my last one. Okay? A projectile is launched straight up. This is the first one, right? Okay. From ground level with an initial velocity of 272 feet per second. Write an equation to model this situation. Okay. So, S is going to equal what? Give me the equation. What? Anything else? Because we're launching it from the ground, so we're launching it from 0, 1. If you wanted to put +0, we would. All right, I like it. Question B says, when will the height of the object be 960 feet above the ground? My question to you is, how can I solve that algebraically? How can I solve that algebraically? Where S is? Yep, exactly. I'm gonna substitute 960 for S. Bless you. Bless you. Bless you. Okay, now, algebraically, how can we go about doing this? Set it equal to 0. Which way you want to go? You want everything going to the left or everything going to the right? To the right? Okay, I'm okay with that. So we're going to subtract 960. So that's going to give me 0 here equals negative 16t squared plus 272t minus 960. Love it so far. Can we make it even easier on us? What would our greatest common factor be? Well, let's try 16. That's the biggest number. That's the smallest number, right? Does 16 go into 272?
Yeah.
How many times? 17 times. Does 16 go into 960? Yeah, how many times?
60.
60?
Yeah.
Okay. So instead of dividing by 16, I'm going to divide by negative 16 here. Okay? I'm going to divide by negative 16 there because then that gets me with a positive squared value. So that would be 0 here equals t squared. Did we say 17?
Yeah.
Oops, cap breaks. This one should be minus. Yes? My question to you now is this. Are there two numbers in this world that when multiplied together give me positive 60 and when added together give me negative 17? Yes, ma'am. I love those two numbers. 0 equals open t minus 12 and t minus 5. Negative 12 and negative 5. When multiplied together, give me positive 60. When added together, give me negative 17. Okay, almost done. Now what? Now I can set those factors equal to 0. T minus 12 equals 0, so t is going to equal 12. T minus 5 is going to equal 0. T is going to equal 5. Whoa, wait a second. Tap the brakes. Let's stay in our lane. Can that object be at 960 feet twice?
Yeah.
Okay.
Yes.
Talk to me about when it's going to be at 960 feet. So it means it goes higher than 960 feet, right? Okay. So on the way up, it hits 960 feet, and then it goes up even higher, and then it comes back down and hits 960 feet again. So it's at two locations that happens. Happens twice. Love it. Okay. So when will the height of that object be at least 960 feet? Yeah. Okay. Why? Because it's at least. Okay. So now at least, is that going to be the equals inequality or the unequals inequality? Like greater than, less than, or greater than equal to, less than equal to?
Less.
With the equals part?
Yeah.
Do we agree with the equals part? Because at least means it still could be 960, right? Okay. Or I could have said brackets or parentheses. Okay. All right. So what is my brackets or parentheses? Brackets. Okay. And but what's going to go in betwixt them? 5 and 12, right? Because we just found out that on the way up, Nora told me on the way up, at 5 seconds, it hits 960 feet, then it keeps going up, and then it comes back down, and it comes back to 960 feet at 12 seconds, right? So that means it's at least there between 5 and 12 seconds, right? Okay, love it. Okay. When will the height of the object be at most 960 feet? We're going to have two of them, right? We're going to have an up one and then a coming back down one. Okay? So give me the up one because that one's easiest. Ooh, I heard negative infinity to 5. Because the object is okay. So we can't start it until 0, right? Okay. So inclusive on 0, are we inclusive on the 5? Meaning bracket or parentheses.
Yeah.
Bracket because it says at most. Okay. And then between 5 and 12, it's up above. Comes back down and hits 12. Okay? Then what? When does it end? It can't end at 0. Why? Because it's a parabola. Parabolas are symmetric. Okay? So if it takes 5 seconds for it to get up, you drop the phone right here at my feet. If it takes 5 seconds to get up to 960 feet, then on the way down, it's going to take 5 seconds to get back down from 960 feet. Okay? Now, what if we didn't know that? What could we do? Solve for the zeros on our original equation, right? Yep, we could go back to our original equation, divide by negative 16t, and then we would get t minus 17. Okay, and we'd set that equal to 0, and then we would get 17 seconds there for it to be in the air. Okay? So our object is in the air for a total of 17 seconds. Good times. One thing that we have decided as Rockville Lynns, the three-headed monster, I don't remember it, in Greek mythology, isn't there a name for the three-headed, like, dragon? I don't remember what it is. So that's what we call ourselves, the three-headed dragon, because we're all the same beast. Okay? Is that you guys probably need some more extra practice. So we went and found some extra practice ones. Okay? Now these are not going to be collected, but they are recommended. So if you have struggled with any of the topics that we've done so far, here are some extra problems that you could be doing, okay? Which we had half sheets at some point in time. Yeah, I know, I thought we had it printed off, but otherwise, so if you wanted to write these down and, or snap a picture of it, or something like that, all of these, ooh, we gotta shrink that down so that we can, maybe that's all, yeah. Okay, EOO means every other odd kind of a deal. So all of these, sorry if I walk through your picture. I'll get out of the way. One of the things that when I'm a wedding officiant, I've married a couple of people already,
Really?
some friends and stuff, yeah. And so one of the things, if you're ever a wedding officiant and it comes time for the bride and groom to have their first kiss, as the wedding officiant, you should do this.
That's so valid.
And then say, you may now kiss the bride, or you may now kiss for the first time, kind of deal, because then you're not in the picture.
Otherwise,
Yeah.
it's just like your face.
Otherwise, it's just me. It's me watching two people make out. Yeah. Yeah. Okay. All right. Which is good. Right. So there's that. So when you go, where you can find those problems, if you go to your Canvas, okay, which is under apps on your Chromebook, if you go to your Canvas, you should all be registered in a pre-calculus class. You click on the pre-calculus class, and that will take you into the pre-calculus class. Then I'll go student view on this one so that you guys see what I start. So it's what you see. Then
The last 3 shows of it.
listen up. Then you scroll down to the roadmap for chapter P. And within the roadmap for chapter P is a PDF of the text. And so we can have that. If you are not a PDF of the text person and would like a hard copy of the textbook, you just gotta let us know and we can let you check out a textbook. We're not going to just give everybody a textbook because it's rare that we do anything out of the textbook other than give you more problems, more select problems.
Is this graded on like if the answers are all right, should we check with people and make sure they're all right?
You could check right there.
That would work.
Or I think you could check
Yeah, it's on
right there.
Wow.
Yep.
Sweet
Yep.
new.
Yep. Yep. We post everything.
Okay.
Yep.
Oh,
Yep.
there. I'm happy.